The modern agricultural landscape is defined by an ongoing quest for efficiency and precision, driven by global demand for food and the imperative to optimize resource utilization. As new harvests arrive, vast quantities of fruits and vegetables stand ready for collection, presenting significant logistical and operational challenges to farmers worldwide. This endeavor necessitates a blend of traditional labor-intensive practices and cutting-edge mechanical and robotic solutions. This detailed exploration delves into the diverse and often ingenious methods employed by farmers to bring produce from the field to the market, highlighting technological advancements and their economic and technical implications. One significant example is the cultivation of pumpkins, a crop that has historically occupied a substantial portion of global vegetable cultivation areas. To manage the immense scale of pumpkin harvests, specialized large-scale machinery is indispensable. A prominent example is the pumpkin harvesting and crushing machine. This equipment operates by first aligning pumpkins into straight rows. Large, spined wheels then efficiently lift each pumpkin from the ground. Internally, a sophisticated 4-part crushing drum breaks down the pumpkin flesh, meticulously separating all the seeds. This method is particularly vital for the pumpkin seed oil industry, where high-volume processing is crucial for economic viability, leveraging the extensive cultivation of varieties like the Styrian oil pumpkin. However, many farm operators still prefer to harvest whole pumpkins, opting for machines equipped with an extended conveyor belt system designed to gently lift the pumpkins from the ground and transfer them into storage crates, minimizing physical damage. In certain regions, particularly for specialty markets or smaller farms, manual pumpkin harvesting remains the preferred method. Farmers utilize robust shears to cut the sturdy stalks and carefully lift each heavy, thick-skinned pumpkin. This labor-intensive task requires considerable physical strength and meticulous attention to avoid bruising the fruit, which can impact market value and shelf life. The mature, typically yellow pumpkins are then loaded onto transport vehicles, destined for sale to distributors and retailers. The harvesting of apples, another globally significant fruit, demonstrates a fascinating spectrum of technological integration. Advanced orchards are increasingly employing drones for apple harvesting. These drones are equipped with sophisticated imaging systems that scan and identify ripe apples based on color and size. Subsequently, robotic arms, designed for gentle and precise manipulation, delicately pick the fruit. This innovation represents a leap towards precision agriculture, reducing reliance on manual labor while maintaining fruit quality, particularly for premium varieties. Alongside this, tree shaking machines offer an effective bulk harvesting solution. A large white tarpaulin is spread around the base of the apple tree, after which the machine grasps and vibrates the tree trunk, causing ripe apples to fall onto the canvas. This method enables the harvest of thousands of apples rapidly without harming the tree, significantly boosting productivity, especially for apples destined for processing, juices, ciders. However, manual harvesting continues to be the predominant method for apples intended for the fresh fruit market, where fruit integrity and appearance are paramount. On average, a skilled worker can harvest approximately 60 kilograms of apples per hour using traditional methods. To enhance productivity while retaining quality, many farms combine manual harvesting with mechanized conveyor systems. Harvesters gently place picked apples onto a conveyor belt, which transports them directly into crates, reducing handling and potential damage. This combined approach allows each worker to achieve a yield of up to 250 kilograms of apples per hour, a notable increase in efficiency for a labor-intensive operation. Mangoes rank among the world's most consumed fruits, with global production reaching approximately 40 million tons annually. The sheer scale of demand necessitates efficient harvesting strategies. For smaller farms, a large contingent of manual laborers is often employed. Easily accessible lower branches are typically harvested by hand. For mangoes situated on taller trees, pickers use long poles equipped with a soft snare or net to gently dislodge and catch the fruit, preventing damage from falling. In more technologically equipped farms, hydraulic ladders or elevated platforms are utilized, allowing harvesters to reach desired heights to pick mangoes directly and safely. After collection, the mangoes are typically washed with water and carefully stacked into baskets, awaiting distribution. The meticulous post-harvest handling is critical to preserve the fruit's delicate skin and extend its shelf life, particularly important for export markets. Carrot harvesting showcases the capabilities of fully mechanized root vegetable operations. Specialized harvesters move along the rows, their front mechanisms adeptly pulling both the foliage and the carrot roots from the soil. The carrots are then conveyed into the machine, where a screening system removes soil and excess leaf material from the tops. The cleaned carrots are then pushed onto a conveyor for discharge directly into collection bins at the rear. Without these advanced harvesters, meeting the annual global demand for millions of tons of carrots would be a monumental logistical challenge, underscoring the efficiency gains of mechanization in the sector. Conversely, artichokes are primarily harvested manually to ensure the quality of the delicate flower buds. Farmers navigate the plant rows, gently plucking artichoke buds that have reached the optimal size and maturity. These harvested buds are then tossed into large baskets carried on their backs. This method prioritizes quality and minimizes damage to individual buds, crucial for their premium market positioning. Avocados, a fruit experiencing burgeoning global demand, are also predominantly hand-harvested. To boost productivity, farmers have developed auxiliary tools consisting of a compact cutting head and a collection pouch attached to a long wooden pole. This device allows a gentle twist and cut, with the fruit dropping safely into the pouch, preventing bruising. In more modern farms, hydraulic ladders or elevating platforms are deployed to lift workers to optimal picking heights. From these stable platforms, farmers can selectively pick mature avocados, further ensuring fruit quality post-harvest. The increasing global appetite for avocados underscores the need for such specialized yet often labor-intensive harvesting techniques. Blueberry harvesting exemplifies the application of technology to delicate fruits. Specialized machines are designed to straddle blueberry bushes, using vibrating bars along the plant's trunk to gently dislodge the ripe berries. A system of chutes and conveyor belts beneath the machine collects and transfers the fruit into crates. The machine operator, seated aloft, has a clear view of the rows, facilitating a rapid and precise harvesting process that minimizes fruit loss. These machines are pivotal, enabling American farmers to achieve a substantial production of 283,000 tons of blueberries, ranking the U.S. as the second largest producer globally. This mechanization is critical for meeting the scale required for both fresh and processed blueberry markets. Kale harvesting, traditionally a physically demanding task requiring farmers to remain bent for hours, is also witnessing a shift towards mechanization. Modern kale harvesters feature intricate systems, such as one with 600 stainless steel rods designed to gently pull kale leaves from the stem. The kale is then transported within the machine to remove soil and small stones adhering to the roots. Such a machine can harvest an impressive 80,000 kale plants in a single day, dramatically reducing labor intensity and increasing output. California, a global agricultural powerhouse, is the dominant producer of broccoli in the United States, accounting for up to 92% of total national production. Farmers typically harvest broccoli when the head is firm and has not yet opened. A sharp knife is used to cut the stalk horizontally, leaving a portion of the stem for easier packing and storage. While manual harvesting is common for fresh market broccoli, specialized machines are also employed. These machines cut rows of broccoli plants and convey them to a belt system. Workers stationed along the belt then manually sort and remove any plants that do not meet quality standards, ensuring that only premium broccoli is packed directly into crates in the field, maintaining freshness during transport to supermarkets. California's almond industry is equally impressive, recognized as the world's almond capital with an annual production nearing 900,000 tons. The harvest season transforms vast fields into bustling zones of machinery. Tree-shaking machines, equipped with powerful robotic arms, firmly grasp tree trunks and shake them vigorously for a few seconds, causing almonds to rain down. This technique not only saves time, but also protects the trees, ensuring their productivity in subsequent seasons. Following the shaking, sweeping machines, resembling giant brooms, consolidate the fallen almonds into neat rows. Vacuum-like machines then collect these almonds into storage compartments for transport to processing facilities. The highly mechanized nature of almond harvesting underscores the need for efficiency in high-volume, commodity-driven agriculture, though it also raises concerns regarding water usage in arid regions like California. Peach harvesting presents a different challenge due to the fruit's delicate nature and susceptibility to bruising. Traditionally, peaches are harvested manually, with farmers carefully picking each fruit. For higher peaches, ladders are used. Extended hours in the orchard often leave pickers' hands covered in the fine dust from peach fuzz. As cultivation expands, semi-automatic harvesting equipment is becoming more common. Workers operate on either side of a peach row, picking the fruit and gently placing it onto a conveyor belt. The peaches are then transported along the system to a packing area at the rear, reducing manual carrying and handling. Tomato harvesting has evolved significantly from a seasonal event, July to September, to a year-round operation, largely thanks to greenhouse cultivation. For fresh market tomatoes, many farmers still opt for manual harvesting, walking through rows, using shears to cut tomatoes from the vine, and placing them gently into collection baskets. In modern farms, robotic harvesters are emerging. These robots utilize intelligent programming, image sensor systems, and artificial intelligence to precisely position themselves between rows. They can differentiate between ripe and unripe fruit, gently grasp mature tomatoes, and detach them from the stem. For large-scale field tomato production, specialized mechanical harvesters are deployed. These machines lift the entire plant, gently vibrate it to separate the fruit, and convey the tomatoes for sorting. Workers on either side of the conveyor remove damaged fruits, while standard quality tomatoes are deposited into crates and transferred to trucks for consumption. Such modern harvesters contributed to a record global tomato production of 45.8 million tons in a recent year, highlighting the impact of technology on agricultural output. Cucumber harvesting on large fields often requires a collaborative effort. Manual harvesting involves individuals walking through rows, gently picking ripe cucumbers into baskets. Modern cucumber harvesters accelerate this process, moving along plant rows and using vibration or gripping mechanisms to separate fruits from the vine. The cucumbers are then transferred to a conveyor for on-site cleaning and sorting, enabling tons of cucumbers to be harvested in a single day. The harvesting of apricots, a significant crop in regions like the United States with over 4,800 hectares of cultivation, often employs tree-shaking machines due to market demand exceeding manual harvesting capacity. Two main types of shakers are common. The first features a chassis that surrounds the tree trunk, activating a vibrator to vigorously shake the trunk, causing apricots to fall into an integrated chute within the machine. The second, simpler type, involves spreading a tarpaulin at the tree's base, followed by a mechanical arm clamping and shaking the trunk, with apricots falling onto the canvas for collection. Both methods minimize damage to the apricots during the bulk harvest. For large and heavy fruits like watermelons, harvesting demands a combination of human strength and machine support. Farmers manually pick watermelons from the field and pass them hand to hand onto a conveyor belt. The watermelons are then sorted and stacked into large crates for transport. Advanced machines now automate this further, moving through fields, lifting each watermelon onto a main conveyor. Intersecting belts continuously transfer the watermelons into an enclosed compartment at the rear. These machines can harvest dozens of tons daily, far surpassing manual methods in speed. California dedicates approximately 46,000 acres to strawberry cultivation, with most harvesting performed manually to ensure the highest quality for the fresh market. Workers use specialized hand carts to navigate the rows, relying on experienced pickers to identify ripe fruits for immediate field packing. Similarly, citrus fruit harvesting in Texas, with 60% of its production sold fresh, remains predominantly manual. Farmers carefully pick each fruit to preserve its intact skin and freshness, as mechanical methods often cause damage detrimental to fresh market sales. Kiwi harvesting also requires meticulous manual care, with farmers gently picking clusters and placing them into bags, simultaneously removing excess leaves to maintain quality. In Italy's Valpolicella region, the first step in creating renowned Valpolicella wine is the precise harvesting of grapes, often conducted at night when cooler temperatures help preserve natural acidity and enhance fruit flavors. Specialized lighting systems aid skilled workers in selectively picking the best grape bunches. Cauliflower harvesting often involves a team of specialized vehicles moving slowly through rows, while pickers cut heads and place them onto a conveyor, removing damaged florets to ensure high quality. Large-scale manual harvesting is also employed for onions in California, where dozens of workers move rapidly, pulling onions from the soil, trimming roots and leaves, and quickly placing them into crates or bags. Banana harvesting is a highly coordinated, physically demanding task. When a bunch is ripe, one farmer cuts the stem, while another catches the heavy bunch on their shoulders, quickly carrying it to an overhead cable system. This synchronized teamwork is essential for efficiently handling large, heavy, and perishable fruit bunches. Durian harvesting, known for its heavy, thorny fruit, is potentially hazardous and requires absolute coordination. Farmers climb tall trees to cut the fruit, which is then skillfully caught in a sack below to prevent damage or injury. Sweet potato harvesting is also a labor-intensive process, with teams of farmers stooping to collect each potato, gently shaking off soil, and placing them into buckets, which are then quickly transferred to trucks. Celery is harvested directly in the field with specialized vehicles featuring conveyor belts. Workers cut celery stalks near the base, place them on the belt, and other workers trim excess leaves and pack the celery into crates on site to maintain freshness. Spanish farmers harvest approximately 170 million kilos of prunes annually for drying, with precise timing being critical for optimal sweetness and preventing cracking. Mexico's nopal, cactus paddle industry, involves consuming and exporting around 800 million kilos annually. Farmers harvest nopal early in the morning to preserve freshness, selecting paddles 18 to 23 centimeters long, ensuring softness, thickness, and absence of sharp spines. Prickly pear harvesting requires caution due to external spines. Farmers use special tongs and thick rubber gloves to gently collect each fruit. Pineapples are harvested manually, with farmers bending to cut ripe fruits and expertly tossing them into baskets strapped to their backs. This continuous, rapid workflow culminates in loading the pineapples onto trucks for packing. In China, the unique harvesting of dried red dates involves farmers using sticks to knock dates from branches onto the ground. Blowers then align the fruits, and vacuum machines quickly collect them, reducing manual labor. India, the world's largest papaya producer, harvests around 5.2 billion kilos annually. Despite the scale, papaya orchards operate without rush, each fruit carefully hand-picked and arranged in organized piles. Cherry harvesting occurs early mornings when temperatures are cool, with each cherry manually picked with extreme care to avoid damage to the fruit or its delicate skin, preserving the stem for better shelf life. Bell peppers are also manually harvested, with farmers walking rows, collecting firm, bright peppers into buckets for transfer to collection points and packing into market-ready boxes. The Red River Valley, a major U.S. sugar beet region, produces about 44% of the national output, largely thanks to modern precision machinery. Harvesters lift beets from the soil, an integrated system shakes off dirt and trims tops, and clean beets are conveyed to a large rear silo. Raspberry harvesters use flexible plastic rods to gently shake ripe fruit from bushes, with workers removing leaves and unripe fruit before raspberries are placed in plastic trays. High-efficiency machines harvest spinach in France, using blades to cut stalks close to the ground, with air jets removing dust and debris. Blackcurrant harvesters use rotating shafts to gently vibrate ripe fruits onto a conveyor, where they are pre-sorted. Cranberry harvesting is iconic, entirely water-based. Machines slowly move through red-stained water, rotating drums dislodge berries, which are then sucked via pipes and conveyors into collection flumes and large storage containers. Date palms, due to their height, necessitate mechanical lifts for harvesters to reach high clusters. Dates are either carefully picked and arranged in trays or gently shaken into mesh bags tied below, balancing quality with efficiency. When grape leaves turn brown, indicating readiness for drying on the vine, specialized machines move along trellises, shaking plastic rods to separate dried grapes, raisins, onto an underlying conveyor. Some vineyards use netting systems to facilitate on-vine drying, minimizing vine damage during shaking. Potato harvesters gently dig soil, bringing roots and tubers to the surface. Conveyor systems clean potatoes, and sensors sort them by size and quality in the field. Texas cotton farmers harvest approximately 2.2 billion kilos annually, thanks to advanced, efficient machines that gently encase each white, fluffy boll, separating fibers from capsules, removing seeds and impurities on site. In rose fields, each bloom is carefully hand-picked as it fully opens, preserving petals and natural fragrance for high-value products like essential oils and perfumes. Lavender harvesters precisely cut full, healthy clusters, transferring them to conveyors. These machines enhance productivity while maintaining the delicate aroma and appearance of the flowers. In Dutch cabbage plantations, large harvesting machines operate like mobile factories. The machine head gently pulls cabbages from the ground, excess leaves are trimmed, and heads are sorted before being loaded into storage crates, ensuring fresh cabbage availability even in winter. Most sweet corn is harvested with modern machines equipped with specialized cutting heads that cleanly remove ears from stalks, automatically separating and placing them into storage compartments. In a recent year, the U.S. sweet corn industry achieved an estimated production value of around $993 million for fresh and processed markets. The future of agriculture is increasingly intertwined with advanced machinery, reflecting a global market for agricultural equipment projected to exceed $189.4 billion by 2030. This technological evolution extends beyond harvesting to encompass various critical farm operations, from precision weed control to sophisticated livestock management, fundamentally transforming productivity, resource efficiency, and animal welfare. A prime example of innovation in crop management is the use of laser weeding machines. These machines first scan the entire cultivated area to accurately distinguish crop plants from weeds. High-intensity laser beams are then precisely directed at the weeds. The rapid temperature increase induced by the laser damages cellular structures, inhibiting further weed growth. Each laser pulse lasts only a few milliseconds, ensuring that cultivated plants remain unaffected. A laser weeding machine of this caliber can remove weeds up to 80 times faster than manual labor, offering a chemical-free and highly efficient alternative to traditional herbicides. For the application of pesticides or liquid fertilizers, automated sprayers like the JAG R150 UGV unmanned ground vehicle. Despite its relatively small size, this machine boasts a substantial tank capacity of around 100 liters. During operation, a pumping system draws the solution from the tank and propels it through spray nozzles distributed along the machine's body. A sophisticated control system automatically adjusts the flow rate and spray pattern based on the machine's speed, ensuring uniform coverage across the cultivated area. This machine can achieve a maximum efficiency of up to 5 hectares per hour, epitomizing precision agriculture's potential for optimized input use and reduced environmental impact. Hemp, a plant characterized by its dense growth and fibrous stalks, is typically harvested mechanically rather than manually. The front cutting unit employs rotating blades to sever the plants at their base. Immediately afterward, the stalks are guided into an integrated processing unit via a conveyor belt system. A distinctive feature of the internal cutting unit is its use of a single, large, rapidly rotating blade to cut stalks into sections 30 to 60 centimeters long. This method is specifically tailored to the robust, fibrous nature of hemp, facilitating smoother and more efficient downstream processing for various industrial applications, including textiles, bioplastics, and construction materials. To enhance soil fertility and support stable plant growth, farmers often use specialized machines to spread treated liquid fertilizer into the soil. Upon reaching the designated position, the vehicle's pumping system activates, generating pressure to expel the fertilizer. The liquid is then channeled through a system of tubes and sprayed uniformly across the machine's width by strategically placed nozzles. These machines can operate continuously, day and night, with capacities approaching 64,350 liters, capable of irrigating dozens of hectares. Such efficiency is crucial for large-scale nutrient management, optimizing crop yields while minimizing runoff. In tomato fields, advanced machines are employed for planting. The soil preparation unit at the front continuously plows the soil, creating loose and uniform planting beds. Immediately following, an automatic planting system precisely places seeds in each bed. Finally, the machine performs hilling, pushing soil over the seeds to form raised beds that promote better potato growth and reduce pest and disease incidence. In a single pass, these machines can simultaneously plant 8 rows of potatoes, significantly outperforming manual planting in both speed and efficiency. The global volume of processed tomatoes for a recent year was estimated at 45.7 million tons, highlighting the industrial scale of this crop. For weed control in challenging terrains, many remote-controlled mowers are employed. Equipped with a track system, these machines maintain firm traction on steep and uneven ground, capable of operating on slopes of up to 55 degrees. Users control the machine remotely via a handheld device. The cutting head, positioned between the tracks, features rapidly rotating steel blades that cut and mulch surface vegetation. The cutting height is flexibly adjustable from 50 to 185 millimeters, suiting diverse applications. In extremely arid regions, farmers frequently rent stone collection machines to clear the soil surface before cultivation. These machines feature robust metal structures designed to withstand significant impact forces when operating on hard, stony ground. As the machine moves, steel tines rake and propel stones, gravel, and other obstacles onto a conveyor belt. The collected material is then elevated and deposited into a large container within the machine's body. Furthermore, many farmers prefer smaller cultivators, such as the Tiller TM150B, due to their lower cost and ease of use. Once started, the machine is simply pushed forward, and its high-speed rotating blades penetrate, cut, and turn the soil, creating a looser, more aerated bed. In Meaux-la-Taverne, southeastern France, lavender fields flourish, ready for harvest. Specialized harvesters move along the flower beds. The machine's head gently lifts the flowers, draws them inward, and cuts the flower stalks. The processed flowers are then transferred via a tube and deposited directly into a container mounted above the machine's body. France's lavender cultivation area spans 28,000 hectares, underscoring the scale of this aromatic crop. In Canada, hay bales harvested at the end of the season are processed by ray busters for reuse. These machines, commonly found on small to medium-sized farms, feature a container with high-speed rotating knives that shred and chop the introduced hay. A large hay bale can be processed in approximately 2 minutes. Farmers typically cut straw into 2 sizes, about 7.6 centimeters for livestock bedding and a finer size for animal feed, maximizing utility. Tulip bulb harvesting involves a multi-stage mechanical process. First, water is poured into a vehicle-mounted container. Once activated, digging blades excavate the soil layer containing the tulip bulbs. Dirt and leaves are separated from the bulbs by a vibrating sieving system, and the bulbs are then deposited into the water container for 2 additional washes. The cleaned tulip bulbs are then transported by conveyor belt into another wagon destined for a processing plant in preparation for sale. Lemon harvesting, with an estimated global production of 10.2 million tons in a recent year, is increasingly mechanized. Harvesters move along rows, with the front section designed to navigate between trees. Rotary shafts gently rotate, brushing through branches to dislodge ripe lemons. Collected lemons are stored in a chute and then deposited into a container. This machine also adapts for apple harvesting. Recent innovations include mechanical kiwi pollination machines. Pollen is mixed with water and then sprayed onto female flowers by nozzles. The system automatically targets blooming female flowers, ensuring a successful pollination process, especially critical in addressing shortages of natural pollinators or irregular pollination. The machine moves slowly at 1 to 2 kilometers per hour until all flowers are pollinated, and it can also be adapted for kiwi harvesting. Agricultural plastic film covering machines aid in soil moisture retention. Farmers attach a roll of black plastic film to a bar at the rear of the machine. As the machine moves, the film unrolls uniformly over the loosened soil bed. Wheels then bury the two edges of the plastic film, securing it firmly against wind or water. This plastic cover helps maintain soil moisture and can also suppress weeds, creating a microclimate beneficial for crop growth. In the realm of livestock management, modern machines have become indispensable. Robotic milking systems, numbering over 35,000 in dairy farms globally, exemplify this advancement. A rotary system with 60 milking stalls can complete a full rotation in just 9 minutes, milking up to 250 cows per hour twice daily. Nearly 90% of cows voluntarily enter the system after only 4 milking sessions, achieving near maximum efficiency within 45 minutes per session. Upon entry, cows are identified via a collar-mounted device, allowing operators to view detailed information on a control screen. Each robotic arm features a 3D digital camera to precisely locate teats, recording cow height for accurate cup attachment and automatic detachment at session end, maintaining udder health. During milking, the cow's identification color changes to dark green, transitioning to gray upon completion, typically 5 to 6 minutes, indicating progress toward average milk production. The journey of fresh milk from farm to table is fully automated. Milk is extracted from cows at their natural body temperature of approximately 37 degrees Celsius. It flows through stainless steel pipes to a chilled storage tank. Once full, the milk is transferred to insulated tankers, maintaining a consistently cool temperature during transport to prevent bacterial growth and preserve freshness. At processing units, milk undergoes rigorous testing, homogenization, and pasteurization to ensure consumer safety, then packaged into various sizes for delivery to supermarkets and schools.
I want you to make me uncomfortable.
For animal feed, pelletizing machines streamline the process. Farmers prepare and uniformly mix essential ingredients like cornmeal, rice bran, fish meal, minerals, and vitamins. Proper mixing ensures consistent nutritional value and prevents machine blockages. The mixture is poured into the machine's hopper. When activated, a compression shaft rotates continuously, generating high pressure to compact the materials into pellets. Pelleted feed improves handling, digestion, and nutrient absorption for livestock, poultry, and fish compared to traditional powdered feed. Automated stable cleaning machines reduce manual labor and enhance cleaning precision. Via a touchscreen control panel, farmers select the appropriate cleaning program. The machine navigates the barn using ultrasonic sensors, accurately stopping at the end of its route. This minimal human intervention significantly reduces manual effort. Equipped with 2 high-power spray nozzles, the machine projects strong water jets up to 5 meters high, easily removing manure, dust, and residue from floors, walls, and troughs. In modern poultry farms, maintaining litter quality is paramount for flock health and productivity. The Exo robot, an automated device, addresses this by loosening and improving litter conditions. Using LiDAR-based sensors and a navigation system, the robot operates effectively in enclosed spaces without disturbing the flock. It aerates the litter, preventing crusting and moisture buildup, thereby reducing the risk of footpad dermatitis and respiratory diseases in poultry. The robot continuously monitors stable air quality, including temperature, humidity, and ammonia levels, transmitting this data to a central control system for remote monitoring and adjustments via computer or smartphone. Automated egg collection and processing systems transport eggs from nesting areas to the processing unit. These robots handle eggs gently, minimizing breakage and contamination. Advanced machines sort eggs by size and quality, performing essential tasks like washing, grading, and packaging, preparing thousands of eggs per hour for transport, significantly reducing labor costs while consistently meeting market standards. Automated egg packaging systems use electromechanical structures for precise and secure handling. Each egg is identified, moved, and positioned correctly in seconds, adapting to different carton types and sizes, ensuring optimal packaging volume and market quality. Poultry vaccination, once time-consuming, is now made faster, more precise, and safer with automatic and semi-automatic vaccine injection machines. These machines typically use a pneumatic system. The user pulls a device drawer until it stops, automatically filling a syringe with the required vaccine dose. The drawer is then gently pushed back, and the vaccine is applied via a nozzle to a specific area of the chick or bird, ensuring accurate dosing without waste or under-vaccination. Periodic sheep dipping protects sheep from parasites that cause skin diseases and reduce wool quality. This process is done after shearing, when wool is shortest, allowing the solution to reach the skin effectively. The system has 21 spray nozzles, strategically placed for uniform coverage. An electronic sensor triggers copper solenoid valves connected to each spray line as a sheep enters the chamber, stopping spraying when the sheep exits. This system can process up to 600 sheep per hour, typically twice a year, ensuring flock health and reducing disease outbreaks. During harvest season, sheep farmers use automated weighing and sorting systems instead of manual methods for selling animals. Once identified, a sheep steps onto an integrated electronic scale, its weight automatically recorded and compared against predefined criteria, e.g., retain, sell, breed. Based on this data, the system automatically controls sorting gates to direct each sheep to the appropriate group. Such systems can process up to 800 sheep per hour, sorting into 3 to 5 directions, ideal for large farms during busy seasons. In large-scale cattle operations, drones are essential for monitoring and managing herds efficiently. Their ability to fly high and cover vast areas quickly allows farmers to assess cattle health and behavior without physical traversal. Countries like Australia and parts of the United States, especially large ranches in Texas and Montana, are adopting drone technology for cattle management. Drones can scan and monitor entire herds, identify lost animals or those showing signs of illness. Thermal cameras and sensors can detect injured or sick animals. Once a problem is detected, drones can fly closer, programmed to specific altitudes and speeds to gently guide herds in a desired direction. The drone's sound and movement naturally encourage animals to move, helping farmers direct them to pastures or corrals. Helicopters are also used in horse farming for effective herd management, especially for wild or free-ranging horses on large land expanses. Instead of riding or walking rugged terrain, farmers use helicopters to monitor, guide, and gather herds. For health checks, branding, transport, or sorting, helicopters fly low along specific routes to guide horses. The engine noise and aerial movement create natural pressure, encouraging horses to move in the desired direction. Helicopters also monitor health and movement of different horse groups, with GPS systems allowing remote data observation and recording, saving time and reducing stress on horses. Even off-farm, breeders can monitor livestock via smartphones or computers. Surveillance camera systems provide real-time views of cattle health, behavior, and living conditions. A clear advantage is early disease detection, e.g., cows not eating, moving abnormally. Instead of manual checks, producers monitor camera feeds and respond quickly to problems. External surveillance systems also protect livestock from predators, enhancing farm security and reducing losses. Treadmills, commonly associated with human fitness, also play a vital role in horse care, training, and rehabilitation. They allow trainers to precisely control training intensity and speed, difficult to achieve with traditional methods. On a treadmill, horses can build muscle, improve endurance, and recover from injuries in a controlled environment under expert supervision. Adjusting the treadmill's incline targets specific muscle groups. These machines accommodate high-speed training, particularly beneficial for racehorses, improving endurance and performance regardless of weather or terrain. In modern slaughterhouses, the use of electrical stunning machines for pigs before processing is critical for animal welfare and food safety compliance. Stunning renders the pig temporarily unconscious before slaughter, significantly reducing pain and suffering. The pig is placed in a compartment where its head or body contacts electrodes. The operator applies correct voltage and duration according to technical standards, ensuring effective stunning without severe tissue damage. This method passes a brief electric current through the pig's brain for about 5 seconds, disrupting neural activity, causing immediate unconsciousness without instant death. When done correctly, the pig enters a state of insensitivity, unresponsive to external stimuli, allowing for a more humane and hygienic slaughter process.